Prep IAS. Welcome to the session of Environment Ecology, where we shall be talking about the portion of climate change and biodiversity today. Now, on Saturday, we have had a discussion about the portions of waste and pollution, where we discussed about the concepts of waste management, the legislations associated with the aspect of waste management. And we also talked about the international conventions which are there in place in order to help us manage the waste and in order to prevent the transboundary movement of hazardous waste. And there we observed at certain kinds of conventions such as the Minamata Convention, the Basel Convention, the Stockholm Convention, which is associated with the persistent organic pollutants, and then also dealing with the insecticides, we had the Rotterdam Convention. Now, these international conventions are relevant for your prelims examination. Having said that, you do have certain conventions and certain international organizations which are important even for the mains examination. And as we move ahead into the portion of biodiversity, we shall be taking a look into those particular areas as well. Okay. Rama, that is being that mail that you had sent, it has been taken up and it is being resolved. Don't worry. Okay. Now here, today we shall be talking about the aspect of climate change. Now, in climate change, first of all, questions oftentimes are asked about the consequences of the climate change and the impact of climate change also. What is the impact of the associated aspect of climate change? Why does climate change happen? The concept of forcing global dimming. These are the factors that we are going to study here. Now, here, please Rama, understand it has to follow a process. It is not like you order it from a kind of an e-commerce site where today immediately you will get it resolved. It will take some time. Don't worry, allow us some time, we will get it resolved. That is what I can assure you, that we will get it resolved definitely. Don't worry about it. Okay, kindly concentrate on the studies as of now. Here, when we talk about climate change, we talk about the aspect of global warming and the rising temperatures experienced across the entirety of the planet. How is it that the temperature has been rising up? Now, when we say climate change, is it a new phenomenon? Is it something which has been happening across the planet for the first time? Is it for the first time where the temperature across the planet has been increasing? The answer is no. The planet has gone through multiple different phases where planet has experienced much higher temperatures also. Every few 100 million years, the planet does go through this phase of warming followed by a phase of cooling. That is something which is persistent. Okay. So here, when we talk about climate change, it is not a new phenomena. So then why is it that there is such a large issue around the concept of climate change? The reason behind that is very simple. It is not the fact that the planet is warming. It is the rate at which it is warming. The rate at which the planet is warming is significantly accelerated. Now, in general, previously also when the planet had gone through this phase of warming or cooling, generally in the natural process, it takes its own due course of time, allowing many species to adapt with the changing climate, with the changing conditions, with the changing scenarios, the changing food habits, the changing resources. So the planet did it in a slow and steady manner. Sometimes the change did happen quite suddenly and it led to mass extinctions. Right now, again, it is the rate of planet change which is very accelerated. The warming is happening at a very fast rate. And as a result of that, that is why we experience this condition. So here, when we talk about it, so basically, has happened multiple times. Previously, the rate of warming has significantly accelerated, leading to substantial, irreversible changes in the ecosystem. Now, this has been triggered earlier, around 90 million years ago, or when you talk about the condition around 400 million years ago. Whenever that sudden change of planet has happened, it has basically happened because of, let's say, sudden volcanism across the entirety of the planet. Now, that has increased. Previously, what it would do is that when you had volcanic eruptions, millions and hundreds and thousands and millions of volcanoes erupting on a daily basis across the entirety of the planet Earth, the amount of carbon dioxide and the various other gases released would be so very high that it would start absorbing the heat. And that is what led to the warming of the planet. This time again, it is the carbon based compounds which have a higher prominence in the atmosphere, which is leading to the warming. But this time, the carbon dioxide which is present in the atmosphere, which is leading to the warming, has been induced by human activities. So, this climate change is induced due to human activities. So, here, climate change has been induced by human, or rather anthropogenic emissions of CO2, leading to increased greenhouse effect and global warming. Okay, and the conditions of global warming. So that is why climate change is such a worry. That ever since the time of the Industrial Revolution, the amount of carbon dioxide and carbon compounds that we have been releasing in the atmosphere, now that has substantially increased the level of warming. Whenever, throughout the history of the planet, whenever the carbon dioxide proportion in the atmosphere has suddenly increased, it has mostly been on the back of volcanic eruptions, as I told you. And whenever that has happened, the entire planet's temperature has risen up drastically. Having said that, presently, if let's suppose the humans were not to be present on the planet, this is the phase where the planet Earth is considered to be stable. This is one of the stable phases because rarely do you experience a large scale tectonic movement or a large scale planetic or the endogenic forces in action. Rarely do you experience a massive volcanic eruption happening anywhere. So, this is a stable period of the planet Earth. Now, in this stable period of planet Earth, the temperature is supposed to be consistent. And whenever throughout the history of the planet, the temperature has remained consistent for a larger period, species have thrived. Newer species have come into existence, right? Much more newer species have come into existence, what is known as speciation. And there, the biodiversity has always increased as a consequence of it, as a resultant of it. Having said that, this time, even though this is the stable period of the planet Earth, we have created an unstable situation by releasing endless amount of carbon dioxide, methane, nitrous oxide, water vapor into the atmosphere. Now, this brings us to the concept of global warming. Now, when we talk about global warming, what is it? It is a phenomena of increasing average air temperature near the surface of the earth for the past few years, ever since the Industrial Revolution, since the time of the Industrial Revolution. Now, here, it has the influence of human activities since the beginning of Industrial Revolution has been deeply woven into the very fabric of climate change. And this global warming, why is this global warming happening? Because due to increased CO2 emissions, more trapping of heat, of terrestrial radiation released by the planet, leading to rise in temperature. Okay, that is something that you experience. So basically, again, it is a byproduct of the warming of the planet. The warming is happening due to the greenhouse effect. Now, what is the greenhouse effect? Now, this is something that you have already covered in the portion of geography. But just to give you a gist of it, brief gist of it, let's suppose this is the surface, this is the atmosphere. Okay, let's suppose this is your surface. Now, the shortwave solar radiation, which is very high in energy, right? The incoming shortwave solar radiation. Now, that incoming solar radiation is going to heat the surface. It is going to heat the surface. So, as the surface gets heated up, then what happens as a consequence? This surface gets heated up. So, the surface also starts acting as a hot object. So, thereby, the surface starts emitting a radiation of its own, which is lower in energy, comparatively lower in energy. And this radiation is basically lost into space. That is what provides the cooling of the planet. Some amount of that energy is retained. Right? So you have the outgoing terrestrial radiation. Terrestrial radiation. However, when we talk about this terrestrial radiation, ever since there has been an increasing concentration of various gases like CO2, water vapor, then even nitrous oxide, methane, carbon monoxide, all these gases. Whenever we see an increased concentration of these gases, which we also refer to as the greenhouse gases, sulfur hexafluoride, hydrofluorocarbons. So, wherever you have the concentration of gases like CO2, CH4, etc. So, what they do, they basically trap the outgoing terrestrial radiation. They don't allow the outgoing terrestrial radiation to escape, and that is re-radiated back to the surface, reheating the surface. Again, there will be a terrestrial radiation trying to cool the surface. Again, it will be reheated. So that is where they start reflecting the long wave terrestrial radiation. The outgoing terrestrial radiation generally is of low energy and is in the form of long wave, right? So that is a long wave, low energy terrestrial radiation. So these gases, they end up trapping this particular outgoing terrestrial radiation, and they re-radiate it back to the surface, leading to increased heating. So more number of gases means more amount of heating. So that is why ever since the time of industrial revolution, the number or the amount of gases such as carbon dioxide, etc., that we are discharging into the atmosphere, those amount of gases have increased quite rapidly, quite substantially. So that is why you experience an increased temperature across the planet for the past century and more. So this is basically the impact of the greenhouse effect, and this is because of the increased amount of gases: water vapor, carbon monoxide, nitrous oxide, methane. All of these are your gases which come into the category of greenhouse gases. Okay. Now, having said that, when we talk about the greenhouse effect, what it is, so basically the Earth's energy budget is further complicated by the greenhouse effect. The greenhouse gases, mainly carbon dioxide, methane, nitrous oxide, and so on, absorb some of the infrared radiation produced by the Earth's surface. As I told you, it is low in energy. The net effect of absorption by greenhouse gases is to increase the total amount of radiation emitted downwards towards the Earth's surface and the lower atmosphere. It continues to heat the planet, leading to temperature rise. Continues to heat the planet, leads to a rise in temperature. Okay, leading to a substantial rise in temperature across the entirety of the planet's surface. That is what is greenhouse effect. Now we come to another concept that is known as radiative forcing. Now, what is this radiative forcing? So, here the term, let's assume we don't know anything about it, as would be the case with many of you. Let's assume we don't know anything about this concept of forcing. But forcing, you are forcing something, isn't it? And it has got to do with the radiation. So, the incoming solar radiation. So, you have many different factors and fundamentals in the atmosphere. For example, let's suppose if this is the ground surface. Let's suppose this is the ground surface. Here you have a very dense cloud cover. Very dense cloud cover. Now, in case where there is very dense cloud cover, then the solar insolation, because the cloud, regardless of whatever color it might appear from the ground surface, it might appear absolutely dark, black, etc. But from above, the clouds always look whitish, pitch white, right? So from those areas, it will start reflecting back the solar rays because it is whitish in appearance. So as a result of that, what will happen? That means the ground surface will receive lesser amount of heat. So because of the cloud, can we say that there is a cooling event in action? Isn't it? We can say that because of the cloud cover, the rate of heating has reduced. It has basically brought about some amount of cooling. Now, suppose you have in one of the places the presence of, over the ice sheets, etc. Let's suppose you have the presence of black carbon compounds. Let's suppose compounds of black carbon. Now, this black carbon, obviously, it is almost a no-brainer because of its coloration, because of the compound. It will absorb heat, right? So all the solar rays which would ideally be reflected, they will start being absorbed in this region, isn't it? So as they get absorbed in the region, what happens to the rate of warming? The rate of warming in this region will be accelerated. Here, rate of warming will be accelerated, isn't it? Very good. Rate of warming increases. Here, due to the cloud, the rate of warming decreases. Let's suppose you have sulfur dioxide. Sulfur dioxide has got a property as a gas, it goes higher up, and sometimes it combines with very small water molecules and forms microscopic aerosol droplets, what are known as aerosols. So it starts forming small droplets, which is whitish in appearance. Whenever sulfur dioxide forms these droplets, it is basically the droplet formed as per a reaction between sulfur dioxide and water, and thereby it is whitish in appearance. Now think about it, that from a region a lot of sulfur dioxide has been released, and there all that, I will give you a detail about aerosol, don't worry. So here all that sulfur dioxide is released, it combines with water to form these whitish, very, very tiny droplets. Now think about it. Ideally, the solar rays which are going to come in this area, now upon falling on this white particles, these solar rays immediately will be reflected back here itself. Whitish color reflects more. So here on the ground surface, what will happen? It will provide some amount of cooling. That is why whenever you have volcanic eruptions, wherever you have massive volcanic eruptions, in the gases which are released during the eruption, substantial chunk of substantial chunk of sulfur dioxide is also released. Now that sulfur dioxide forms these very tiny aerosols at a higher altitude, and that starts reflecting the solar rays. That is why volcanic eruption immediately provides a level of cooling. Immediately, in the long run, because of the carbon dioxide added, volcanic eruptions will lead to warming, but in the short run, they will provide cooling. So as you can see, be it a region of ice cover, be it the black carbon, be it the cloud cover, be it the sulfur dioxide, all these various agents of nature, they can accelerate the rate of warming, or they can basically revert the rate of warming. So whichever events they accelerate the rate of warming, those are known as the factors of positive radiative forcing. Whichever phenomena reverses the impact of warming, that is referred to as a kind of a negative forcing, because you are reversing the present trend. Okay, so radiative forcing is a measure of the influence a given climatic factor has on the amount of downward directed radiant energy impinging upon the Earth's surface. Positive forcing is exerted by climatic factors that contribute to warming of the Earth's surface, and negative forcing which cool the Earth's surface. So here, when we talk about positive forcing increases the rate of warming, and whenever we say negative forcing, reverses the process of warming. Okay. So you have various different factors of nature, agents of nature, for example, cloud formation, release of sulfur dioxide, presence of freezing of the occurrence of freezing across the planet's surface, or the emission of black carbon by anthropogenic activities. They can accelerate the rate of warming, or they can revert the process of warming. Okay. Accordingly, you will basically come across the various different types of events or the activities, and whether it leads to the condition of warming or cooling. So here, if you observe this, so for example, carbon dioxide, it it will have the potential of increasing the temperature, but it will provide some amount of warming, right? Methane provides level of warming. Like that, some of the halogenated gases will also form aerosols, which will start reflecting back the solar rays. But then halogenated gases, they will impact us in the long run by depleting the ozone layer and thereby again suddenly increasing the heating process. Then, for example, if you observe black carbon will provide warming, but let's suppose sulfur dioxide, SO2 based aerosols. SO2 based aerosols, they provide cooling. SO2 based aerosols. Okay. Now, clouds, they will radiate, reflect back the heat or the solar rays from a higher up itself. So that provides a rate of cooling there also. So basically, these are the various different factors which can either end up increasing the amount of heat absorbed or they can provide cooling events. So negative forcing means cooling, positive forcing means warming. Okay. Now, let us take a look at few of the greenhouse gases here. Now, these are few of the greenhouse gases that we are looking into, but please don't have the perception that these are the only greenhouse gases present out there. No, you have multiple different types of gases which serve or which create that greenhouse effect. These are just few of the gases that we'll take a look into. So here you have water vapor, nitrous oxide, carbon dioxide, and methane. All these are basically the various different greenhouse gases. Now, here we start with the aspect of water vapor. Now, water vapor also has the ability that water vapor is the gaseous form of water droplets or liquid water. The gaseous form of it is the vapor. Now, this water vapor has the ability to absorb and re-radiate back to the surface the terrestrial radiation. So it will increase the level of warming on the surface again. So it is the one of the most potent gases. It is not the most, one of the most potent gases of the Earth's atmosphere. Now here, what you will observe is that it continues to refuel the level of warming. How? So let's suppose across the region on the ground surface, let's suppose here above, you have water vapor. Let's suppose here you have the presence of water vapor, not liquid water droplets. So here, they will basically start absorbing and re-radiating back the terrestrial radiation. So the terrestrial radiation will be re-radiated back. Now this terrestrial radiation will warm the surface again, isn't it? So this warms the surface again. Warming of surface. Now whenever the surface gets warmed up, whatever amount of water droplets are there, there will be evaporation, more amount of evaporation from the surface. As the surface starts getting heated up, you will observe greater amount of evaporation, isn't it? Greater amount of evaporation means what? More amount of water droplets or water vapor getting supplied into the atmosphere. More amount of water droplets supplied into the atmosphere means more absorption of heat. So, greater rate of evaporation. You come across a greater rate of evaporation, and greater rate of evaporation, again, more vapor particles. More vapor particles means again, this is a kind of a feedback loop. More vapor particles means more heat will be absorbed and more heat will be re-radiated back to the surface, heating the surface once again. So that is why warmer the surface, greater the evaporation rate of the water from the surface, and it continues to heat up the surface continuously as a kind of a repetitive process or a kind of a climate feedback loop that is observed. Now, then you have carbon dioxide. Now, carbon dioxide is released both naturally as well as human based activities or anthropogenically. It is not only the case that carbon dioxide is released only by humans. No, carbon dioxide is released in significant quantum naturally also. For example, volcanic eruptions, one of the sources. Respiration by the species, again, we release carbon dioxide. Then, for example, when you carry out deforestation, again, carbon dioxide is released. Decomposition, when it takes place, there also sometimes carbon dioxide is released. So, carbon dioxide is released naturally also. Okay. So, natural sources of carbon dioxide include outgassing from volcanoes, combustion and natural decay of organic matter, respiration by the organisms. All of this adds on to the carbon dioxide. Now, think about it. The potential of providing carbon dioxide in the atmosphere by a natural factor can be very, very high. For example, when we talk about, we are not going to go back 100 million years ago or so, because obviously you had multiple such events where the amount of carbon dioxide in the atmosphere suddenly increased. But in the recent times, in the 1880s, you had a massive volcanic eruption in the form of the Krakatau eruption. Krakatau volcano and the volcanic eruption that happened across the western edge of the Indonesian region, right? Western edge of Indonesia, in the portion of the region of Indian Ocean. That is where you had the Krakatau eruption. It was so massive that the impact of it or the shock waves from it could be felt as far as Turkey in the west and as far as Japan in the north. So you can imagine the intensity and the power, the amount of energy released during that eruption. Now, during that eruption, the outgassing, the amount of gases released, included various different materials, included even sulfur dioxide, etc. But the amount of carbon dioxide which was released into the atmosphere during that eruption, that amount of carbon dioxide basically managed significantly to warm the surface or warm the region, and it is said it will take almost 200 years for the carbon dioxide being released at that point of time to be assimilated back into the atmosphere. So you can think about it. One volcanic eruption can lead to so much amount of carbon dioxide emission that it can take almost 200 years for the planetic atmosphere, for the Earth's atmosphere to digest it all. So here, that is the case of carbon dioxide's natural emission. Now, here you have the natural absorption of carbon dioxide also happens in various areas. Now, the regions where naturally the gases like carbon dioxide, or not regions per se, but let's suppose those particular areas or those particular processes due to which carbon dioxide is naturally absorbed by the atmosphere, those are known as the sinks of carbon dioxide. For example, let's suppose when we talk about sinks of carbon dioxide, of CO2, right? Yes, very good. So here, let's suppose we consider the trees and the plants. Now, most of the all the green plants, right from the microscopic planktons to the largest of the redwood trees, you would observe that due to the process of photosynthesis, they have to absorb carbon dioxide and release oxygen as a byproduct along with the energy, isn't it? So, what they are doing is they are absorbing the atmospheric CO2. That atmospheric CO2 is being absorbed by them due to the process of photosynthesis. So, it is one of those processes which will digest CO2, which will consume CO2, isn't it? Then, for example, let's suppose we consider, this is also, by the way, known as green carbon. This is what is also known as the green carbon. Then, suppose you have the oceanic water. Now, through the air water interface between the atmosphere and the ocean, The ocean absorbs carbon dioxide naturally. Around 25 to 30% of the carbon dioxide is absorbed by the oceans directly, right? Because that is how the oceans are able to allow the marine plants to carry out the process of photosynthesis. That is how the carbon dioxide, which is absorbed, eventually gets converted into carbonate ions within the ocean, which is utilized by the corals to make a calcium carbonate exoskeleton around them, which is utilized by the crustaceans and the mollusks to build a calcium carbonate skeleton or a shell around them. So carbon dioxide is naturally absorbed by the oceanic surface. So here you have the oceanic surface, right? So that is again one of the areas where carbon dioxide is absorbed. So these are basically the areas where we absorb carbon dioxide, where the amount of carbon dioxide is substantially absorbed. So that is what is a sink of carbon dioxide. So the carbon which is absorbed by the oceanic surface, this is also what is referred to as blue carbon. That is what we refer to as the blue carbon. Now, then you have another of this, that is methane. Now, what is methane? Methane is CH4. Methane is produced again by natural processes as well as anthropogenic processes or the human based activities. When we say methane produced by natural processes, so here, understand, for example, let's suppose, even for that matter, volcanic eruption sometimes releases methane. Then, for example, wherever you have the in any kind of vent on the sea floor where gases are being released, that also releases methane, right? That is where under the sea floor, at the bottom of the sea floor, sometimes that methane which is getting released combines with water to form that ice like methane hydrate, which is being mined by countries such as China in order to fuel their demands for energy. So that is where again methane comes into the picture and methane's role comes into play. So that is the role of methane. But even, for example, digestive processes of the species, the cow dung, decomposition, all of that ends up releasing methane, substantial amount of methane. For example, let's suppose even your paddy cultivation, when you are cultivating the paddy crop. Now that paddy crop, the process of cultivation, most prominent process of cultivation in our country is what? Flood irrigation. Now, in the case of flood irrigation, what do? You basically cover the field with, or cover the farmland with significant amount of water, and that water is stagnant in the same region for a long time. And with plants growing in that area, you will have production of methane. And that methane basically, if water evaporates, so that is why whenever water will evaporate from these wetlands, it will release a lot of that methane again, right? Then, for example, so wetland and its evaporation of water, wetlands wetlands basically will produce methane. Okay. Then, in certain areas of the planet, for some period of time now, for a few 100,000 years, you have the situation of standing water or stagnant water, where you have the dead trees. They are deposited. Basically, you have a kind of a water, a small, not a very large and deep water column, but a small water column where you will have the dead remains of the various trees which would have died long time back. Okay. Now, these are what are referred to as peatlands. After millions of years, it is in these areas where you will observe coal formation. So these are your peatlands, right? These are your peatlands. That is marshy areas, covered. in shallow water having dead remains, organic matter of plants and trees, of plants and trees. Now, even in this case of peatlands, if the water evaporates, it will release massive quantity of methane out into the atmosphere. Massive quantity of methane will be released into atmosphere. So that is why there has been a movement to conserve these marshes and these peatlands across the world. But because the or because the climate is warming, because the temperature has been increasing and rising, that is why water across the planet is evaporating at a faster rate. So if this process continues, you will find that these peatlands, wetlands, etc., all of them will start evaporating. And what they will do, they will enrich the atmosphere with carbon dioxide, methane, etc. And that evaporation has happened because of global warming. And again, more carbon dioxide released in the atmosphere means what? More warming. So this will again kick on a feedback loop or a feedback cycle. That is why you need to conserve these peatlands also. Okay. So for example, here, if I give you an example of this, so when we talk about the warming due to release of gases. So, first of all, let's talk about wetlands and peatlands. Methane, CH4, CO2 is present in them. Evaporation of water can lead to release of gases. Right. So it will initiate a climate feedback loop. A climate feedback loop. Now, what is this climate feedback loop? So basically, warming, whenever there will be warming, leads to evaporation due to of water, release of gases, CH4 and CO2, greenhouse effect, again leading to warming. So this process will continue to happen. It will continue to raise the temperature of the planet Earth. Something very similar is at risk in the areas of permafrost. I hope by now we are aware about the conditions of permafrost. Permafrost basically represents the regions which are permanently frozen up. Right. For example, if you consider the regions in higher latitudes, that is the northern portion of Canada, the regions of Greenland, the regions of Europe, the regions of Siberia. Now, many of these areas have been permanently frozen up. So they come into the category of permafrost, where the topsoil, maybe during the warmest of the months, the topsoil might be ice free, but the subsoil, the bottom region, is frozen up. It is consisted of the frozen particles because of prolonged low temperatures, right? So that is basically the case of permafrost. Now there also, there is a same risk. Because in these areas of permafrost, in the lower regions, you will have substantial amount of vegetation, substantial amount of, let's suppose, various different types of remains of plants, animals, crude oil in certain cases, fossil fuel in certain cases. All of them are trapped in that ice layer for centuries, millennia, and for millions of years. You have these regions which have been frozen. Now, as these areas have been frozen, they have trapped all these materials, plant remains, animal remains inside them, many of them undisturbed for millions of years. Now, due to warming and heating, what is happening? That this permafrost is beginning to melt. And as that permafrost begins to melt the lower regions, that means those portions of plant remains, animal remains, now they are ice free. The remains of the organic matter now are ice free. So, what will happen to those remains? They will start the process of decomposition, right? The process of decomposition will be reinitiated in all these areas. And what will this process of decomposition lead to? Release of gases. More gases mean more heating. More heating means more melting. And that is where it gives a kind of a feedback, right? So, here, when we talk about melting of permafrost, Shalu, I have written here that wetlands and peatlands have CH4, CO2, etc., which is present in them. So, if that water evaporates, the water, it is there in the water in the wetlands and peatlands that you have these gases. So, if that water evaporates, then these gases will be released along with them. So, that is where evaporation of water will lead to release of the gases which are included in them, and that is going to exaggerate the rate of heating. Okay. So, here, melting of permafrost. This initiates another climate feedback. So, melting of permafrost means exposing. Yes, Vivek, Antarctica is also permafrost, but there you don't have the threat of melting because you have a very thick ice sheet of 2 to 3 kilometers thick. We are talking about the permafrost which is melting in the region of northern Canada, Greenland, northern Europe, northern portion of Siberia, etc., exposing the remains of plants and animals. That will lead to increased rate of decomposition. Right? Generally, in colder areas, decomposition does not happen, very slowly. That is why in ice structures or in these permafrost, you have the species of animals which have been almost completely frozen for thousands of years without getting decomposed. But what if that ice melts? Then it will decompose, because ice melts means warmer temperature, then it will decompose. So whenever there is an increased rate of decomposition, so that basically means more gases released. Which gases? Carbon dioxide, methane. So more gases are released, and more gases released means more melting. And this is again a climate feedback loop. So that is why there is such a great alarm across the globe in order to conserve the wetlands, peatlands, the regions of permafrost. Now, recently there was a worry which was instigated by the fact that for the past many years, the perception in our mindset was, for the past many decades, the perception in the mindset was that these permanently frozen areas, nothing will happen to them. These will be frozen, and this is a thick ice region, so nothing will is going to happen to them. So what many of the countries, especially the Western European and the North American countries, what they would do, the developed regions, many of them, they would pump in the industrial waste into this ice. That is a perfect way to dispose the waste. Few of them have even pumped in nuclear waste, radioactive waste into the ice, thinking that it will always be preserved. Various different chemical toxins, industrial contaminants, they have been locked in the permafrost for decades altogether, 50, 60 years and more. Now, if that permafrost, as that permafrost is melting, all these toxins are slowly and steadily contaminating the environment around. Many of them have the potential to increase or provide a kind of a positive forcing. So that is why permafrost is always being looked at with an increased kind of alarm. Okay. After more heating leads rain. What we thought in geography class. The heat more leads cloud forming after rain, after causing cooling. Chandrasekhar, your question is not clear. But what I am gaining from your questions is that after more heating, it leads to more rain. Fair enough. But where does it say that if it will rain, then the planet will become colder? It can happen that if there is rain, there will be more evaporation. More evaporation means more water vapor. More water vapor means more absorption of heat, warming of climate, warming of temperature. See, in geography, when we talk about the low pressure and high pressure centers, we are talking about a temporary time duration, maybe of a few hours, maybe of a couple of days, or maybe for 1 month. That if it, for example, right now it is raining in Chennai. So in Chennai, the temperature has reduced. But do you think that we are talking about the long term phenomena of 100,000 years that Chennai will always be cooler? No. In this case, when we are talking about this climate feedback loop or the melting of permafrost, we are not talking that today that permafrost is melting, tomorrow everything will start decomposing, by Friday there will be the release of gas, Sunday will be the hottest day of the planet, next Monday will be the end of the earth. We are not talking about in that scale. We are talking about each of these scales that you talk about. This is basically going to take another hundreds of years, or 50 years, 100 years, something like that. It is not going to happen in a short time window. So when you say that heating leads to creation of low pressure, that low pressure will attract winds, that low pressure will lead to formation of cloud and occurrence of rainfall, you are talking about very short term process. We are talking about the heating of the entire planet. We are no longer concerned with a low pressure, high pressure center. We are thinking about the entirety of the planet as a whole, that if there is heating, what will happen, or what are the factors which will lead to prolonged heating. Is that making sense, or is there still a confusion? Agents of nature, basically, uh, Vivek, when we are talking about cloud formation, SO2, release of SO2, any of these, black carbon deposits, ice formation, these are referred to by agents of nature. Okay, Chituri, when these plants and animals drowned in permafrost, hundreds of maybe millions of years ago, maybe hundreds of thousands of years ago, right? So, for example, many of the even today, for example, if you go to the region of Mount Everest, or if people go to the region of Mount Everest, or any of the mountaineers when they go to climb the Himalayas, across the way and along the way, they find perfectly preserved dead bodies. Many of the dead bodies have been lying there of the expeditioners. Many of the dead bodies have been lying there for more than 50, 60 years altogether, right? So in the process, or in the region of very low temperature, the bodies tend to preserve themselves for a very long period of time. For example, recently you had a species of mouse which was found to be in a perfectly frozen state with food in its mouth, also in the region of permafrost, in the regions across Greenland, northern Canada, where the temperature has been low for many thousands of years, right? So that is basically where they would have gone inside, where they would have been frozen. And Gaurav, volcanic eruption in short run causes warming of planet, but in long run is it can cause cooling by forming. No, a volcanic eruption, Gaurav, on the converse side, in the short run, they will block the sunlight and they will cause cooling. In the long run, however, the carbon dioxide which is released by them, that persists in the atmosphere for such a long period of time, that carbon dioxide provides heating. Yes, Justin, that is true. Um, Santosh, is it true that all the ancient pathogens will release into environment due to climate change? Many of the preserved microbes, if there are such, few of the microbes can come into action. We never know, but it is not the case that if it will be a kind of a biblical plague of sorts. No, that is not going to happen. Okay. What is the reason for not rain in Kuppam in Chittoor, but both sides of a? It is to do with the leeward and the windward side. In this previous concept, all about treatment of soil and water and air, but where that all those take place? Why? Because treatment of soil and water and air. Again, your question is not very clear, Chandrasekhar. And one more question was left. Yes, permafrost is a lower layer. Permafrost is a region which is permanently frozen. Period. A region which is permanently frozen, that is permafrost. When we talk about the permafrost, for example, I hope you are aware where Greenland is. Now, Greenland, if you imagine, the top layer is also frozen, the bottom layer of that is also frozen. So, let's suppose this is the region of the soil. So, here also you will have ice, and the lower portions also will be substantially frozen. Due to increased warming, that top portion obviously is melting every year or so, but many of the areas, this bottom portion is also melting. As a result, when the bottom portion is melting, whatever dead remains of plants, animals, etc., have been there, they will now be exposed to oxygen. Till now, they had no exposure to oxygen or moisture. But as the ice beneath will start melting, they will get exposure to oxygen and moisture. That is when they will initiate the process of decomposition. Okay. Oceanic volcanic eruption also releases large amount of methane. Yes. Can we artificially create carbon sink? Yes, we can. We store, many of the times we are able to trap the carbon dioxide in the atmosphere and then pump it into the lower portions of the ground. And that is again a kind of a sink which we create. Means contamination of soil to get. So where largely in our areas we don't have that large scale industrial contamination, Chandrasekhar. So that is why you don't observe it around you. But across the world this has happened. Many of the times this has happened. Gulf of Mexico had been cleaned like this. Portions of Bay of Bengal had been cleaned because of that oil spill. So these things happen. Is agriculture possible in permafrost areas? Sometimes, when you have during the summer conditions, when the top layer of it becomes ice free, agriculture can be carried out, but only for a short duration. Okay. In permafrost, is there any liquid between upper and lower layer? No, absolutely not. Permafrost means permafrost. Perma refers to permanent, frost refers to ice. Those regions which are permanently frozen. Does sulfur dioxide from volcanic eruption cause cooling by forming aerosol? Yes. Okay. Now, methane, it is the second most important greenhouse gas, and CH4, in terms of its greenhouse warming potential, there CH4 is more potent than CO2. This is relevant for your prelims. This particular fact, right? So per molecule, the radiative forcing is higher. Per molecule, the amount of heating caused is higher, right? So that is why per molecule there is increased amount of heating, increased amount of warming which takes place. Now it is responsible for around 30% of the rise in global temperature ever since the time of industrial revolution. So that is where per molecule methane has got greater potential to warm as compared to carbon dioxide. Having said that, carbon dioxide can stay in the atmosphere for a longer time period, and methane stays in the atmosphere for a very short time duration. So, here, basically, methane exists in far lower concentrations than CO2 in the atmosphere, also. So, that is why, even when we consider per molecule, the potent warming effect of methane is much higher than carbon dioxide, but you have very few molecules of methane in the atmosphere as compared to carbon dioxide. That is why carbon dioxide, generally you consider the volume of it in basically parts per million, but in the case of methane, the volume is considered to be in parts per billion because the concentration of methane in comparison is lower. Concentration of methane is lower in the atmosphere. Okay, so that is the case of or the issue with methane. Now, natural sources of methane include wetlands, methane oxidizing bacteria, volcanoes, seepage vents on the seafloor in regions rich with organic sediment. Now, there also methane is produced. Now, it is in these areas, you will study about it in science and tech itself. So, in these areas, in these regions, methane combines with water to form solid methane hydrates, right? Which are basically a kind of a pale white ice-like formations that you observe on the seafloor. Ice-like in in the sense of their color, not in the sense that they have low temperature. In the sense of their color, you'll find that a kind of a pale white formation of methane hydrate, which is formed on the seafloor. Now, this methane hydrate is used as a or can be used as a source of energy. In South China Sea, already China has been trying to exploit that methane hydrate deposits on the seafloor, can be used as source of energy. So that is what is the methane hydrate trapped along the continental shelf of the oceans and in polar permafrost. Now, the natural sink of methane, basically sink is where the methane gets absorbed or dissipated naturally. So the primary natural sink for methane is the atmosphere itself, as the methane reacts readily with the hydroxide ions within the troposphere to form CO2 and water vapor. So that is why methane in the atmosphere can dissociate naturally. In a natural process, it will react with the OH ions and form CO2 and water as a consequence. And another natural sink is soil, where methane is oxidized by bacteria. There also, methane is absorbed from the atmosphere directly. Now, this is a kind of a representation to give you an idea about the sources of methane. Now, in this, you will observe that methane is produced naturally also, and methane is produced artificially also. So, for example, when we talk about wetlands, that produces methane, seepage on the seafloor, etc., that also produces methane. So, these are your natural sources. Other than that, fossil fuel burning produces methane. Rice cultivation, as I have told you, rice cultivation is where you have standing water for a long time. And when that water evaporates, it releases or discharges a lot of methane. Biomass and biofuel burning also produces methane. Waste and its decomposition also produces methane. And then enteric fermentation and manure formation. What is this enteric fermentation? So when we say enteric fermentation, for example, the animals, the species, now when they consume the food, few of them, the food ferments inside their body, and that is where a lot of methane is produced, right? That is why when you carry out animal slaughter, any kind of animal slaughter, it basically releases lot of methane trapped within the body, right? Over a period of time, many of the time it also happens that as the dead body starts decomposing, it will release a lot of methane. That is why you would have come across those events or those visuals where a large whale or a shark might, dead shark or a dead whale might have washed ashore near the coastline, and it would have started inflating. After it is dead, it would have started inflating, right? And suddenly, if it is not controlled, it bursts open. Why does that happen? Because in the interior of the body, decomposition has been initiated by the microbes. And that decomposition starts producing methane, carbon dioxide, etc. And all of that gets trapped within the body. The body starts inflating like a balloon. And that is when it finally bursts open. So, for example, when you consider cows, buffaloes, all of them, now, as they chew on the cud and they have the process of digestion where it is referred to as chewing the cud, where they will consume the grasses, they will store it in the esophagus, they will then regurgitate it, and again they will chew it off. That is when eventually it ferments inside the body. So, in that process of fermentation, again, you will find that lot of methane is produced. Okay, that is one of the reasons why nowadays you will find the activists across the world, the climate change activists of across the world talking about going vegetarian, because animal slaughter will always release methane regardless of whichever kind of animal slaughter, it has the potential to release methane. Now here, when we talk about the global methane tracker, so, as per International Energy Agency's latest update on the global methane tracker, it was found out that global energy industry was responsible for 135 million tons of methane which is released into the atmosphere in 2022, only slightly below the record highs of the pre-pandemic days. And the energy sector, this is again relevant for your prelims. This fact is relevant for your prelims. Energy sector across the globe accounts for around 40% of the total methane emissions attributable to human activity, second only to agriculture. So agriculture is the most pronounced human activity in terms of methane emission and methane release into the atmosphere. And agriculture includes the animal husbandry or the rearing of animals process. That is included in that. So that is included. So that is why when we talk about the total amount of methane which is produced, it is jointly very high in the case of energy sector and agricultural sector as well. Okay. Now, is it true that cow is the only animal that releases oxygen during respiration? I don't think so, my dear friend. No. Don't we use CH4 for energy generation? Yes. So how is that CH4 attained, Ravi? When we talk about CH4, basically it is in the form of biogas, isn't it? So how is biogas produced? So you have large digester plants in the backyards where basically all the dung, all the cow dung, the kitchen waste, etc., litter, all of that is stored there. Some amount of water is added in that digester container and it is left there. And that is where after some time the sludge formation happens, methane is formed, and that sludge which deposits the decomposed part, that is separated to be used as manure, and more waste is added. So you have consistent supply of methane there. Okay. IEA stands for International Energy Agency. International Energy Agency. Okay. Now, here, when we talk about the sources of methane, bacterium, Gaurav, is again, you have various different types of microbes which produce methane. For example, even dimethyl sulfide, eventually, which is produced by the few of the microorganisms, they also end up forming methane later on. Last line. Last line. Is it a complicated English in the last line? Today, the energy sector accounts for around 40% of the total methane emissions attributable to human activity, second only to agriculture. Means the largest contribution of methane emission by human activity is agriculture, followed by that is energy. Do I need to write it down? Okay. Largest human contribution to methane emission. I think it is a simple English, guys. Is basically agriculture followed by energy industry. Is it understood now? Or is there any doubt in that? Okay. Now you have other various different components, other various many types of gases, which also in a way instigate and promote the greenhouse processes and also lead to a kind of global warming and greenhouse effect is accelerated. For example, ground level ozone, nitrous oxide, when we say fluorinated gases such as sulfur hexafluoride SF6, right? Then SF6, for example, then hydrofluorocarbons, HFCs, perfluorocarbons, PFCs. These are your fluorinated gases, aerosols, many of them, they contribute to warming. Now, when we talk about aerosols, what are these aerosols? So, aerosols are extremely solid, extremely small solid particles or very small liquid droplets suspended into the atmosphere. So very small particle size that they can remain suspended. Think about it. If the particle is large enough, it will fall on the ground. It is only when the particle is very tiny, minuscule in size that it is able to suspend itself in the atmosphere, isn't it? So aerosols consisting of solid particles can be placed in the atmosphere primarily by large dust storms, volcanic eruptions, and even soot particles. Soot refers to black carbon. Black carbon. Okay. So even that black carbon which is released from forest fire, wildfire, or even human activities. So now many of these particles are very, very small. As I told you, sometimes few of the gases can combine with water vapor or liquid water droplets and form very tiny liquid droplets which are suspended. That is aerosol. Liquid aerosol in the atmosphere primarily consist of water droplets in which active chemical compounds like SO2 can also be found. Now, wave action, whenever it happens in the oceans, whenever you have a large wave which will strike the oceans, immediately a small tiny sea spray, small droplets of that sea water, many of the times they are carried by the wind and released into the atmosphere. So all of that is what? It leads to those particles getting suspended into the atmosphere, and that is what leads to warming. So here, wave action in the oceans may actually send water droplets and small particles of sea salt in the atmosphere as well. Okay, so these aerosols, depending upon their nature, their quality, and depending upon what kind of chemical compound is present in them, they can either absorb or they can reflect back heat, causing positive or negative forcing. For example, black carbon. Black carbon will always provide heat, right? So it is a case of positive forcing. SO2 based aerosol. they will provide cooling. So it is an example of a kind of negative forcing. Okay. Now, over a period of time, for the past few decades now, the problem of air pollution has been very persistent. The problem of pollution in general has been very persistent across the globe. Now, due to increased amount of emission, increased amount of various different gases, dust particles, etc., which are emitted into the atmosphere, now these tend to block the solar rays. Right? When the pollution is very high, the total amount of solar rays reaching on the Earth's surface is not very high anymore. So they will start blocking the solar rays. As a result of that, in any particular area, the total amount of solar rays which are received, that is very, very less. It provides a kind of a dim condition on the ground surface where the ground is not lighted up anymore. So the ground is very, very dim in that situation. Right? So oftentimes what happens is that because of the numerous different types of particles here, don't worry, the SMEs will reply to you. Please have patience. The SMEs are going to reply to you. Okay. So here, many of these various different types of pollutants, particles, etc., they remain suspended in the air. So as a result of this, a particular region on the ground surface will receive lesser amount of solar rays. The solar radiation which ideally would reach the ground surface, that reduces quite significantly. And that is where the ground surface is cooler. Lesser light, amount of light, and when you have lesser amount of light produced, this light is received. That is what is referred to as global dimming. Okay, so global dimming is defined as a decrease in the amount of solar radiation reaching the Earth. Now, during the 70s, the 80s, and the early 90s, these amount of pollutants were very extraordinarily high in concentration over the regions of Europe, over the regions of North America. That is where global dimming would be widely observed. Having said that, since that point of time, that region has cleaned itself substantially, and now you observe this event happening across India, over the region of China. For example, during these months, in the northern part of the country, hardly there is a case of a very bright condition of sunshine, is there? Mostly you will have the pollutants, they will block the sunlight, and you have a kind of a reduced amount of sunshine which is received. So the centers of global dimming in the past few decades, they have shifted from the region of Europe and North America over to the region of China and India now. So here, various regions observe different levels of global dimming. Southern hemisphere has generally observed very reduced or almost negligible amount of global dimming. Why? Because when we talk about southern hemisphere, land is very less in comparison to the water body. The presence of land is very less, and also in the southern hemisphere the population is also very less. So that is where northern hemisphere has witnessed more than around 4 to 8% of the reduction of these solar rays, of these solar insolation. Okay. Okay. Now, after this, here, regions such as parts of Europe and North America, if you observe, they have observed partial recovery from dimming, while parts of China and India, they have experienced increase in the case of global dimming. Now, what are the effects of global dimming? When we talk about the effects of global dimming, so here, water in the northern hemisphere has become slightly cooler over a period of time. But again, this is a temporary effect. This leads to slower evaporation and generation of lesser water droplets. This further causes the reduction in the amount of rain produced in certain parts of the globe, resulting in drought and famine conditions. This is one of the effect. Other is decrease in sunlight or solar radiation will negatively impact the process of photosynthesis in the plant. So, as a consequence of this, plant productivity reduces, productivity reduces, and no, it is not winter specific. It is something which is prominently observed due to the contaminants and the pollutants. For example, during the summer months, you have the formation of photochemical smog that happens because of the presence of the various amount of nitrous oxides, VOCs, etc., that you find in the atmosphere. Now, that again reduces the amount of solar rays coming on the Earth's surface. So, impacts the energy transfer in ecosystem. Okay, so that is the overall impact of global dimming. Wave, Ananya, when we talk about wave action, so let's suppose if you have witnessed anytime the wave in front of you, if you have observed the wave crashing onto the rocks in front of you, you would basically have observed that as the wave comes in, now as it crashes, lot of small particles and droplets and a kind of a spray is released immediately, isn't it? Lot of these small particles and spray that is released. Now that is your sea spray. Now, many of that is carried by the wind into the region of the upper portions of atmosphere, and that also forms these aerosols because they consist of small, tiny droplets of salt also. The sea salt, the different types of salt which are present in the oceanic water. So, and many of the times it also happens. Let's suppose wave is coming towards the coastline. From some distance, the wave is coming to the coastline. Now, this wave will have some winds. It is experiencing. Now, there also small sprays will be discharged, right? That is why, if ever you have ridden a small dinghies or the small boat in the sea, right, where they take you deep into the sea in order to take you for whale watching or dolphin watching, or even for that matter, if for adventure sports activities, whenever you would have ridden on the boat deep into the sea, you would have basically experienced a lot of these tiny droplets consistently in the air around you. That is your sea spray. That is salty in nature. That has got salt particles. Now, if there is a wind action, it can easily carry it up in the higher portions of atmosphere. And as we have studied it in geography, basically many of these sea spray, the small particles, they can also serve as the base for the cloud formation. Okay. Yes, Ashirvad. Global dimming can lead to temperature variation. What are the pollutants suspended? Santosh, think about it. For example, you have the photochemical smog. Photochemical smog is a brown haze which develops over the cities during the summer in the presence of sunlight. Now, how is photochemical? What is photochemical smog? Reactions of hydrocarbons along with the formation of peroxyacetyl nitrate. Now, that is going to, if it forms a brown haze, it will reduce the amount of sunlight. That is dimming. Clouds don't lead to dimming. Clouds lead to the reflection, absorption of solar rays. That is not included in the portion of dimming. Let's suppose you have a lot of this immediately, for example, after the festival of Diwali, you have a lot of these pollutants in the sky. That, in a way, prohibits the complete amount of solar rays reaching the ground surface. That will lead to dimming. Dimming of light can lead to temperature inversion. Yes, Akansha, good. Energy industry is equal to petroleum industry only. Why? Even energy extraction. exploration, marketing, the when you have the fuel pumps, refineries, that also comes in the energy industry. Transportation sector, in terms of the consumption of energy, that also comes under the energy industry. uh, can global dimming decrease global warming in the immediate short run? Yes, Gaurav, it can. And can bioaugmentation can be used to treat radioactive contaminated soil? Also, has the bioremediation been used to treat the MIC contaminated soil and groundwater around the? No, not significantly to a meaningful extent. No, that has not been done, and that is because the uh, detailed scientific study about the amount of contamination, etc., for a long period, so you need to carry it out almost immediately for it to be effective in the immediate aftermath of it. But for a long period of time, the various different reports that the scientific community would present, the IIT advisory council, etc., all of them would largely be ignored, because understand, this was not something that the government was very keen to showcase, that okay, this gas tragedy has happened. So that is why everything was supposed to be kept under wraps. Okay. What about dark clouds? Dark clouds, again, understand what is dimming. It is not blocking of sunlight, it is dimming. Dimming is when you reduce the intensity of light. That is reduced when you have the pollutants in the air. Clouds help in lowering of temperature, but also increase in temperature by reflecting terrestrial radiation. Yes. When you consider low level clouds, they will provide cooling. When you consider high level clouds, such as cirrus clouds, they will radiate back the terrestrial radiation, thereby leading to warming. Okay. Now we come to the portion of deforestation. Now, what is this deforestation? Deforestation is basically in an existent area where you have the presence of a forest cover. If you cut down the trees and the vegetation, that is what is deforestation. Deforestation, existing trees, existing forest land are getting cut off. Now, whenever you carry out deforestation, at that instant itself, cutting down the trees releases lot of carbon dioxide, releases lot of methane. So, cutting it down releases CO2 and releases methane. Okay, along with the fact that ideally, if there would have been forests in this area, they would have served as sinks of carbon dioxide. Now, these regions are serving as emitters of carbon dioxide. Now, deforestation is carried out for a variety of purposes. But most prominent reason for carrying out deforestation across the globe has been, one of the most prominent has been the extension of agriculture. Bringing new areas under cultivation has been one of the most prominent reasons for the process of deforestation taking place. One of the most prominent ones, where the existing trees basically are cut off to clear the land in order to cultivate, right? That is one of the most prominent things that you will come across. So, other than that, infrastructure building, lumbering activities, collection of wood, timber, etc., that is also going to lead to deforestation. Now, deforestation has got a variety of detrimental impacts that it can create on the ground surface. A large variety of detrimental or disadvantageous effect. First of all, release of greenhouse gases. Huge amount of greenhouse gases of carbon dioxide and methane are released when you cut down a tree. A large tree, for that matter, would have stored a lot amount of carbon. All of that will be released. Secondly, in an area where you carry out deforestation, there is a disturbance in the rainfall pattern. Rainfall pattern gets disturbed. How? We are observing it in the northeast. Pattern is disturbed. So basically, for example, let's suppose, and this is why many of the areas of northeastern region, including Arunachal Pradesh, Manipur, Mizoram, sadly, there the irony is that the percentage of land under forest is highest in that portion of the country. But the sad part is the rate of deforestation in that part is also highest. Now, understand, under normal conditions, under natural conditions, on a day to day basis, the region of very dense forest, very dense forest, is it going to be dry? No. The regions of very dense forest, they have a way to recycle water. Water circulation is done, water cycle is maintained there on a day-to-day basis, on a daily basis. When you have these forests carrying out photosynthesis, the process of transpiration, these will be discharging some amount of vapor into the atmosphere. Substantial amount of water vapor would be provided into the atmosphere. Now, this vapor which is provided into the atmosphere, this amount of vapor which is supplied to the atmosphere, now this vapor sometimes leads to the cloud formation, right? And it can bring about periodic rainfall. Okay, so there, not excessively huge amount of rainfall, but periodically what is required for that land area, because generally, naturally, you will observe in your surrounding also. Go and visit the region around you. If suppose you are fortunate enough to be living in one of those rural areas, find out a region where you have heavy density of trees. Try to pick up the soil there. Try to feel that soil. You will find that the soil is generally moist. Go to a region of a cropland, farmland, or in general the soil anywhere. You will find that the soil otherwise is drier. The soil near the trees are generally moist because they retain water. Slightest amount of rainfall happens, it retains water, the soil holds water. So that is why these regions are generally water sufficient. Right? Now, let's suppose you have cut down these trees. Now, there is no supply of moisture to the atmosphere on a regular basis. Means what? Now, you are dependent on the moist winds to bring you rainfall, if at all. Now, moist winds can be sporadic, it can be non continuous, it can vary due to climate change. So, as these moist winds will come, suddenly a large cloud cover, immediately excess amount of rainfall. The soil is also loose now. So that soil will be carried over. There will be soil erosion, surface runoff. Very little amount of groundwater recharge, but flash flood events or flooding events will be consistent. Again, let's suppose the flood has occurred. After that, all the water which was there has drained off somewhere, carried by the topsoil. So now you have no cloud formation anymore. So for a prolonged period, again, you will experience a dry season, right? So you have a very heavy spell of rainfall followed by a prolonged dry season. Again, a very heavy spell of rainfall, very dry condition, right? So rather than having a continuous small amount of rainfall available through and through, the rainfall pattern gets disturbed where short spells, short spells of very heavy rain followed by drought like conditions. Okay, so that is what you observe in the case of deforestation, right? Then, other than that, groundwater recharge is prevented. Biodiversity obviously will be impacted due to deforestation. Impact on biodiversity. Biodiversity leads to increased heating and warming. Increased warming. Why? Because now you will have more carbon dioxide in the atmosphere. Earlier, these forests were absorbing carbon dioxide, but now you have cut them over. More carbon dioxide in the atmosphere, more amount of warming. There will be, as a result of that rising temperature in that region, impact on the water cycle, on water security. More heat waves will be observed because now that the ground is dry, even if there is a spell of lack of rains for 10 to 12 days, the ground temperature will rise up substantially and you can experience a condition of a heat wave. Floods, etc., will also be a commonality. So, deforestation is the permanent destruction of forests in order to make the land available for other uses. About 300 billion tons of carbon, 40 times the annual greenhouse gas emission from fossil fuel, is actually stored in trees. The deforestation of trees not only lessens the amount of carbon stored, it also releases carbon dioxide in the atmosphere. And deforestation releases nearly a billion ton of carbon into the atmosphere per year. Though the numbers are not as high, the rate of deforestation is not as high as compared to the previous decade, primarily because many of the areas have already been deforested. The regions, for example, if you consider the region around Indonesia, every year, tens of thousands of hectares of land is cleared, forested land is cleared for cultivation of palm oil. Now, agriculture or cultivation of palm oil can never compensate the loss of forests, right? So it is the second largest anthropogenic source of carbon dioxide emission to the atmosphere, and impact is also on the water exchange, carbon dioxide exchange between the atmosphere and the terrestrial land surface. It is one of the biggest concern that how water and carbon dioxide exchange will happen, how it will lead to warming, etc. Now, deforestation has decreased the overall global vapor flow from land by around 4%, and that can lead to heat waves, frequent occurrence of heat waves, drought like conditions, crop failures. All of them are an eventuality. The other effects, loss of species. Why? Due to loss of habitat, loss of habitat. Water cycle gets impacted. If you don't have the trees anymore, you won't have anything to bind the soil in its place. So that is where the topsoil is eroded. Topsoil is carried away. Right. Now, the forests provide many different services in terms of the various different products, in terms of the cooling process, etc. So, the quality of life in general will be degraded. Effect on carbon sequestration. Carbon sequestration is about storage of carbon. We will study it in detail very soon. So, carbon sequestration is about storage of carbon. So, if you have massive levels of deforestation, even that storage of carbon is eventually hampered. Disturbance of native people is also a commonality, right? Now, after that, we come to the role of oceans, but we take a break before that. So, we take a 15 minutes break. And no, carbon sink is not sequestration. Storage of carbon is the. Now, carbon sinks are where, for example, the trees are carbon sinks. But what do the trees carry out? The process is sequestration. Okay. So we take a break and we'll be back. Of tree, you will have a large tree for that matter. It will have lot of stored carbon. So when you cut down that tree, CO2 will automatically be released. Okay. Now, now we come to the role of oceans in terms of the climate change. Now, as we have seen that oceans are natural absorbers of carbon dioxide. Naturally, that is in the natural process with the air water interchange and exchange, the oceanic water ends up absorbing substantial amount of CO2. Okay. So normally under normal conditions, through the air water in exchange, oceans absorb CO2. Right? That is the normal process. And that CO2 eventually is utilized by the presence of the various, for example, phytoplanktons. The phytoplanktons which are present in these oceans, they will consume that carbon dioxide to produce food. Now, this carbon dioxide in the ocean is also converted into carbonate ions, and those carbonate ions are also used for the by the various different organisms such as corals, the shell-bearing animals, etc., to build an exoskeleton around them. So here also, this CO2 which is absorbed, basically you will find provides CO2 for photosynthesis. For whom? For planktons and also for example marine plants. Now this carbon dioxide also is converted into carbonate ions, is converted into carbonate ions. Carbonate is CO3 2 minus. Carbonate ions which is used by species like corals to build an exoskeleton around them. Right? Even, for example, the crustaceans, the mollusks, all of them which have a shell, that shell is built up for, or that shell is built up by utilizing those carbonate ions. Right? They will synthesize the calcium ions, they will synthesize the carbonate ions, and then they are able to make that shell. Having said that, if let's suppose the ocean temperature goes higher, ocean, let's suppose, becomes very, very warm. In that case, rather than absorbing carbon dioxide, the water starts releasing carbon. For example, you would have had multiple experiences with the soda bottles or the soft drink bottles like Pepsi, Coca Cola, etc. Now, you would have observed that when it is very cold, it does not release lot of that gas from it. But when it is very hot or when it is significantly warmer, And at that point of time, if you try to open it, lot of gases are released, right? So that is why same is the case, same property happens in the case of the oceans also. In the soda bottle, that is also a carbonated drink which is enriched by the carbon dioxide. Here also, when we talk about the oceans, if let's suppose the ocean temperature increases or ocean temperature rises up, in that situation, rather than being the absorbers of carbon dioxide, they start releasing significant amount of carbon dioxide, right? So here, when the oceanic temperature increases significantly, it starts to release CO2 rather than absorbing CO2. Hence, the oceans become net emitters of CO2. Okay. Now, here also a vicious cycle is in place. What is that vicious cycle? On the ground surface or in general across the planet, due to increased amount of carbon dioxide concentration, we have a rising temperature. Rising temperature means what? That the ocean water will also get warmed up. Marine heat waves are a commonality. Now, when you will have the ocean water also getting warmed up, then what will be the consequence? You will find a scenario that it will start releasing more carbon dioxide, more heating, more amount of heat will be released, so ocean temperature will rise again. So there also a feedback loop kind of a thing is initiated here, right? So high CO2 concentrations, concentration in atmosphere leads to increased warming, increased greenhouse warming, if greenhouse effect leading to increased warming. That increased warming will raise sea surface temperature, sea surface temperature. When there is that release of sea surface temperature, CO2 is released from the oceans, and that further fuels this. So, this is again a kind of a significant feedback loop which is initiated. So, that is again how the oceans, rather than contributing to combating the climate change, they can contribute to climate change, they can contribute to global warming as a phenomena. Having said that, when you have increased amount of carbon dioxide concentrations into the atmosphere, and when more carbon dioxide is getting pushed into the water, now that excess amount of carbon dioxide being pushed into the water can also lead to acidification of oceans. Okay, so increased CO2 absorption by the ocean, increased CO2 absorption by the oceans leads to acidification of ocean. If that CO2 is utilized by phytoplanktons and marine plants, fair enough. But otherwise, under general conditions, you will observe that increased CO2 concentrations, which is lying around in the oceanic water, it tends to form bicarbonate, and it will lead to acidification of the ocean also. Okay, so that is basically the impact. And increased temperature increases surface water temperature and thus stops oxygen supply, which results in, that is also one of the process, Kishore. But in general, the warmer waters, they don't have the capacity to absorb more CO2. They start releasing CO2. They have a limited capacity to hold CO2. That is when they start releasing CO2. Chandrasekhar, I have already answered your query right now. As I told you, whenever you have any of the plant, why is it that animal slaughter releases methane? You have the production. So plants or the trees, when you think about it, don't think about it that it is only wood and there is no system within it and only trees are there, magically it is producing food. I hope you would have studied in your childhood days that even in the large trees, what are referred to as the vascular plant system, you have the presence of xylem and phloem. These are the portions from where continuously food, water, and gases, they are getting supplied and are exchanged. Now, thereby, eventually it is stored. But when you cut down that tree, from those vascular system also, there is that release of carbon compounds, and that is what is released in the form of carbon dioxide and methane. Is that understood? Is that understood, Chandrasekhar? Or were you busy typing the next question in that case? And Santosh, due to rise of sea surface temperature can also lead to attraction. Yes, that can also happen. And Vaishna, increase in sea surface temperature is leading to tropical cyclones. Yes, that is also true, right? So again, Chandrasekhar, I believe that you were basically busy typing the question. Listen to this carefully. When we talk about the trees, trees have the vessels inside them, the vascular plant system. They have the presence of xylem and phloem through which they are able to transport food and nutrients and the gases from one region to another. Now, it is basically carbon which is oxidized to form carbohydrates. The food also produced by plant is in the form of carbohydrates, right? So that is where all the plant products have carbohydrates. Now, if you cut down that tree, from those vessels which were running through the tree, there will be release of carbon which was stored there, which is getting exchanged. All that carbon will be released, and it is not as if immediately it will be released. Slowly and steadily it will continue to get dissipated from those vessels. So that is where that carbon is released in the form of methane and carbon dioxide. Okay, yes. So in every aspect we are destroying our nature because everything is polluted and the absorbers of CO2 are now emitting. So this is horrifying, but now what can be done? Control the amount of emissions. Okay, the emissions which are released. How CO2 absorption leads to acidification? I'll come to it. Now, the world's oceans, they help moderate the Earth's average surface temperature and its climate by removing around 25 to 30% of the CO2 pumped into the atmosphere by human activities. So 25 to 30% of the CO2 released by human activities is basically absorbed by the oceans, but otherwise, in general, across the entirety of the atmosphere, the carbon dioxide which is naturally present is also absorbed by the oceans. Now, here, the oceans also absorb heat from the lower atmosphere and use the ocean currents and the thermohaline circulation to slowly transfer some CO2 to the deep ocean, where it is buried in bottom sediments for hundreds of millions of years. You have carbonification, which happens in certain cases also. Now, the solubility of CO2 in ocean water decreases with the increase in temperature. Thus, as the oceans warm up, Some of their CO2, dissolved CO2, is released into the lower atmosphere, just like CO2 bubbling out of a warm carbonated soft drink. So that is how, when the oceans they get warmer, when the water temperature rises up, the ocean's ability to absorb carbon or retain carbon dioxide reduces, and that is when they start releasing all the amount of carbon dioxide that is present. So they become net emitters. Now we come to the portion of acidification. Now, for some period of time, the amount of carbon dioxide being pushed into the ocean by that air water exchange has been increasing quite significantly. And this has been increasing ever since the time of the Industrial Revolution. So, in the 200 plus years since the Industrial Revolution began, concentration of carbon dioxide in the atmosphere has increased due to human actions. During this time, approximately 142 billion tons of anthropogenic CO2 emission has been absorbed by the ocean, resulting in ocean acidification at a rate which has not been witnessed for the past close to around 7 lakh years. This rate of acidification has not been witnessed. As a result of which, the pH value of the surface water has fallen by 0.1 pH units. What is relevant for you for the prelims is still to understand the fact that even after this, oceanic water is still alkaline. Ocean's average pH is around 8.1, which is still basic or alkaline, but it is reducing. So from 8.1, if it reduces to 8, that will lead to massive changes, because now the carbonate ions won't be available for the species to build a skeleton around them, right? So let us take a look at that process of acidification. So basically here, observe, these are your pteropods. Pteropods, what is the spelling is pteropod. Now these pteropods, these are very small shelled species which you find spread across in the marine environment. These are, by the way, consumed by almost all the species in the all the various different kind of species in the oceans. That is why these are also referred to as the chips of the oceans. Chips in the sense, just like when you have the potato chips or any of these edible chips in the market, everybody consumes them, right? From the young ones to the older population, you give them that, they will consume them as a kind of a snack. It is not the main food, it is a kind of a snack. Just like that, these pteropods, they provide the nutrition requirements. They fulfill the nutrition requirements by for many of the species by providing regular amount of food intake. When you talk about various different kinds of species, from let's suppose stingrays to small fishes, all of them will pluck up these pteropods, these shelled species, and they will continue to eat them up. Now, here, observe what is the reaction happening. Now, excess amount of CO2, which is being pushed in, now that will react with the water and along with the carbonate ions which have been formed from the previously absorbed CO2. Now, ideally, under normal condition, this carbonate ion would be utilized by your corals, would be utilized by these pteropods themselves to build a calcium carbonate shell around them. But now that you have more amount of CO2 being pumped in, that CO2 will now react with the carbonate ion. It forms bicarbonate ions and thereby also releases H plus. H plus means it will become acidic. So in this reaction, carbonate ions present in the oceans are consumed, H plus concentration increases, concentrations increase, and that leads to acidification. Now, if that acidification is going to happen, means carbonate ions are going to be consumed. Now, majority of the shell-bearing animals in the marine areas, if you observe them, majority of these shell-bearing animals, their body structure is very soft and the body is very vulnerable also. So, as the body structure is very soft and vulnerable, if they are unable to build a shell around them, so slowly and steadily, the quality of the shell that they will be deteriorated because now they don't have that much amount of carbonate. So they will have a poorly constructed shell. So automatically they become vulnerable to more predators and natural deaths also increase. But eventually, as these pteropods in the lab experiment, they were put through the various different phases of carbonification as expected in the next 100 years. It was found out that eventually these pteropods, they will have the inability to form any shell around their soft body. So, in a way, exposing that body structure to the vagaries of nature. And that is where they will find it impossible to survive. Corals will find it incredibly difficult to build their shell or the exoskeleton. That can lead to coral bleaching. And coral bleaching, we do know what is the disastrous outcome of that. Dissolved oxygen quantity in the oceans, they will also start to reduce. Now, this acidification, while it will definitely be impacting the case of these marine species, that is the shell bearing species, it also has an impact in, for example, clownfish, where in acidified water they are unable to look at the perfect habitat because these species, they have adapted to a certain condition for a long period of time. They are used to a certain condition for a long period of time, and that is when, as these conditions they keep on changing, they experience a variety of different outcomes. So changes in ocean chemistry can affect the behavior of non-calcifying organisms as well. For example, ability of some fish, like this is the clownfish. Clownfish, their ability to detect predators is decreased in more acidic waters. Studies have shown that decreased pH levels also affect the ability of the larva stage, the young stage of the clownfish, to locate a suitable habitat. So that is where these clownfish, they're so like that. It is not only one of the species which will get impacted, it will have a cascading effect on a large group of species as that ocean continues to get acidified. So here you have a kind of a chain mechanism which indicates what are the various impacts taking place. So, for example, here non-calcifying Baldev are those species which don't form the calcareous shell. For example, corals, mollusks, crustaceans, they form that shell. They are calcifying. Any of the fishes that you consider, they don't have that shell around them. So they are non-calcifying. Okay. So here observe that due to human activities, you have an increased amount of CO2 emission. That increased CO2 will lead to increased greenhouse effect. That will lead to a rise in ocean temperature. This increased CO2 will be absorbed by the ocean, increasing the acidity of the ocean also. Ocean temperature, as it rises up, many of the species would be forced to migrate from one area to another. Increased CO greenhouse effect will also lead to atmospheric disturbances, more tropical cyclones, as many of you have said, more storm formations. So that will lead to disturbance of the coastal ecosystem. Observe what is happening in Chennai. Now, the coastal ecosystem in Chennai would be absolutely devastated. Many of the areas have been flooded, right? So that is where acidity, as it increases, it leads to disturbance of the organisms like coral with a kind of a calcareous structure. And eventually, due to rise of ocean temperature, this releases CO2 in the atmosphere also. CO2. And that again fuels the greenhouse effect. So that is how the oceans, rather than curating the climate, rather than helping us deal with the climate by absorbing CO2, they can end up magnifying the effect of climate change by becoming the emitters and the source of emission for that CO2 also. Okay? Now, as I have told you multiple times previously also, around 90 to 95 million years back, you had a phase where the planet experienced the sudden spurt in volcanic eruptions all across. Everywhere, all across, you had substantial amount of carbon dioxide, which was released due to the volcanic activities. During that period of time, underwater volcanic activities were also very significant. And that is when the concentration of carbon dioxide underwater substantially increased. Very, very high. And historically, earlier also it has happened that the ocean waters, they turn very acidic. But then, slowly and steadily, it takes few millions of years for the oceans across the world to revert back to its normal condition. But again, due to human activities, not due to natural activities, we are in a way replicating that process, endangering the large ocean biodiversity. And please understand, when we talk about the oceanic species or marine species, they have got a very little amount of thermal tolerance. Even if the temperature increases by 2 to 3 degrees Celsius on the ground, the species are able to tolerate that. The terrestrial species are able to tolerate that because historically they have witnessed a substantial change in temperature. But when we talk about the marine species, even if there is a slightest amount of change in terms of oceanic temperature, they will have to migrate. If they migrate to a certain area to escape hot conditions, then what happens? There will again be a scarcity of resource, increased competition, and vulnerable species will again be pushed into the condition of extinction. Okay? Now, now we come to the effect of climate change. What are the impact that we observe due to climate change? Now, here, basically, when we talk about the effect, here, IPCC is one of those organizations, that is Intergovernmental Panel on Climate Change. IPCC is, which was formed in 1988, that is Intergovernmental Panel on Climate Change. Formed in 1988 by World Meteorological Organization and United Nations Environment Program. They came together to form this IPCC. IPCC, again, I will give you the written text about IPCC in the later module also. When we talk about this IPCC, it has played an instrumental, significantly instrumental role in terms of uh, finding out the scientific assessment about what this rate of global warming is, whether the planet is warming due to a certain effect or due to a certain factor, what are the other factors leading to that factor of climate change. Everything, detailed study and analysis of climate change is done by IPCC. And IPCC releases a periodic report, what is also referred to as the assessment report. Assessment report. So that assessment report is released by the IPCC. It is a scientific analysis about the radiative forcings across the planet, the climate feedback loop, the climate tipping point, etc. That is done by IPCC. Now, recently, that is last year, not recently anymore, but then lately, IPCC has released a sixth assessment report. So all the findings that you see, all the mention of radiative forcing, etc., that you see in the PPT, that is as per the IPCC's finding and the scientific assessment. So as IPCC, as per the report, has indicated that a warming of 2 degrees Celsius and its effect on global climate appears to be inevitable, right? Because till now, we have continued to warm the planet. And as per the calculations and the simulations of IPCC, if we continue to consume or if we continue our human activities at the present rate, we might be staring at a temperature which is warmer than uh, than 4 to 5 degrees Celsius in comparison to the pre-industrial era. We are looking at an environment or an atmosphere which is warmer by 4 to 5 degrees Celsius. So even if greenhouse gas emissions are stopped now, some effects such as increased drought and sea level rise will be felt for next 1,000 years. So let us take a look at the impact due to climate change. First of all, there will be a variation or a change in terms of availability of rainfall. Different areas, the amount of rainfall that they receive will change. How? Now, due to higher rate of evaporation, greater rate of evaporation, equatorial regions will receive high amount of rainfall. Amount of rain. Okay. In the polar areas also, evaporation will be initiated due to warming and melting. Greater precipitation, amount of precipitation will be observed. However, this will be a short-term phenomena. So increased precipitation is predicted in the polar and the subpolar regions, whereas decreased precipitation is projected for the mid-latitudes of both hemispheres. All the geniuses of geography who are present here, why is it that mid-latitudes will have reduced amount of rainfall? Do we have a clue? Or do we have, are we in a situation where we are able to interrelate the concept of geography from here? Why is it that mid latitudes will have lesser rainfall in case of warming? Good, Shalu. Very good. That is because mid latitudes receive, Aniket, very good. Mid latitude will basically end up, uh, in general, mid latitude receive rainfall of what cause? They receive rainfall due to frontal formation. Mid latitudes in general, they observe frontal rainfall. Now there has to be a front formation for the occurrence of rainfall. But because of increased warming, you will have the polar air also getting warmer. Equatorial areas are already warmer. It won't be happening that equatorial areas will now have 50 degrees Celsius temperature. No, they will have 40, 45 on an average, but the polar temperature is also rising. It will basically, it might rise above zero. So as a result of that, you will have an overall warm atmosphere, overall warm condition, due to which there shall be negligible or very less frontal formation, and hence almost negligible amount of rainfall created. So here, due to warming, increased warming, polar temperatures rise up. As a result of that, lack of regular frontogenesis, okay, and that lack of frontogenesis basically means lack of frequent rains. Okay, lack of frequent occurrence of rainfall. So that is basically the impact of precipitation. Precipitation near equator is predicted to increase because evaporation, we have studied, is a feedback loop where more vapor means more heating means more evaporation, more cloud formation, more vapor, more rainfall. So changes in precipitation pattern are expected to increase the chances of both drought and flood conditions. This is something that we are already experiencing. This is something that we are already experiencing in our day-to-day lives, where in many parts of the country, you will observe that either there is flood, and as the flood rebates or as the flood abates, then immediately after that you have dry drought like condition, excess rainfall followed by dry conditions, again excess rainfall followed by dry conditions. So that is because of the aspect of climate change. Droughts will become very consistent, so long term climate change can contribute to prolonged droughts. Now here, as the dry conditions, they get more prevalent, the growth of trees and the other plants, that tends to decline, which reduces the removal of CO2 from the atmosphere. The amount of CO2 removed from atmosphere is less. Forest and grassland fires, they tend to increase, which add CO2 to the atmosphere. The amount of CO2 to the atmosphere added is increased. Right? Now, climate scientists project that this will speed up further warming up of the atmosphere. So whenever you have dry conditions, tropical grasslands, thorny forest, they frequently catch forest fire. Example, Africa, Australia, nowadays even North America, Europe, forest fires are very common. Now, whenever you have these instances or incidences of forest fire, what happens as a result? As a result of that, lot amount of carbon dioxide and other emissions are released into the atmosphere, and thereby that will further heat up the surface, further drying the conditions, and this is again going to be a feedback process. Then one of the most visible changes across the planet is the melting of ice and snow. With increased temperatures across the planet, ice caps and the polar ice is melting at an unprecedented rate. So here, what you observe is the case of the North Pole, the region of the Arctic. Now, the red line indicates that the Arctic ice boundary, which was present in 1979. And observe the ice cap now, where if you talk about the thick ice regions, they are restricted quite significantly. Right. So, if the melting continues at this rate, IPCC has even projected that by the year 2040 or 2050, we might be staring at a condition where Arctic might become ice-free for at least 1 year or one season or so. There might be some ice again during the winter, but during one of the summers, it can become ice-free. Think about it. If the Arctic becomes ice-free, all the conditions of atmospheric circulation, the thermohaline circulation in the oceans, everything will immediately come to a standstill. And that is where the climatic changes, the drought-like conditions over Europe, they will predominate unlike ever before. So here, if you observe, this is the image of a glacier where the ice slowly and steadily is melting. This is the image of 1941. The same region, if you observe in 2004, it will appear as if ice has never existed here. Right? So that is because of melting and increased amount of warming. Even Antarctica, the coastlines of Antarctica, which would get frozen every year, and some parts of it would partially melt. That is where you had some of the seasonal plants coming into existence. Recently, you had a situation where Antarctica, the coastlines, they remained ice free for the full year. And you had flowering plants originating there. Right? So the rate of melting is incredibly high. Observe the glaciers. At the same region, observe the glaciers as they would exist in 1941. This is all covered by ice. Now observe in 2004, the ice has started melting from here itself. This is the retreat of the glaciers. Now, this is something that we are experiencing in Himalayas also. In the Himalayas also, there is a substantial retreat of the glaciers. That is, earlier, if the glaciers were melting here, Now the glaciers have started melting from here itself. That is the retreat. Now, if let's suppose all the glaciers of the Himalayas and the snow of the Himalayas were to melt, what would happen? In the immediate short-term future, you would have excess supply of water in that area, excessive supply of water, right? The rivers would get flooded, the regions would get flooded. But what after that? After that flood water goes into the seas and oceans, what after that? After that, the regions where the rivers are moving, they would be very dry, because now those rivers won't have that permanent supply of moisture anymore. So that is where the regions would become very, very dry. Okay, so that is basically where we will face water scarcity. So melting of Himalayan ice in the short term can bring excess supply of water, flood-like condition, but in the long term will lead to consistent drought and consistent dry conditions. Okay. Now, one of the impact of this global warming or climate change is also the rise of the sea level. The sea levels have been rising. Again, let me clarify. When we say that the sea level is rising, it is rising due to, first of all, melting of ice and snow. But one of the major factors due to which the sea level is rising is because of expansion of water. Water, when it is getting heated up, just like any material, it will expand. As it expands across the planet, there will be a sea level rise. Now, again, understand, it is not as if the planet has never witnessed a higher sea level. Historically, if you take a look at the western portion of Africa, you will find evidences in the central portion which indicates that at one point of time, the entire region would have been flooded by a massive wave, by a massive flood, creating a kind, when water moves over an area, when flood happens in an area, the ground conditions, they reflect a kind of a formation like this, deposits like this, right? Now, these deposits, supposedly created by ancient floods, they are many meters high. So think about the scale of floods which would have happened. Long time back, millions of years back, it is estimated that at one point of time in our history, we had the sea level which was around 2 to 5 meters higher. 2 to 5 meters higher sea level means all the coastal areas that you see now across the country, for example, all of them would be completely drowned and submerged. Right? So 2 to 5 meter higher sea level is quite substantial. But this time, it is happening in a very short time span. In the span of the next 2000 years, the sea level is supposedly going, if the rate of warming continues at the same pace that we are doing, the sea level supposedly is going to rise quite significantly in the next 1000 years or 2000 years. So that is where the problem gets exaggerated. So here, when we talk about the global sea level rise and the implications, you had a World Meteorological Organization report of 2022, which was released early this year. So this is World Meteorological Organization. Organization. So in the case of the World Meteorological Organization report, what it has indicated that sea level rise as it is happening, it will first of all flood the coastal areas, the low-lying islands. It can immediately instigate large level and mass scale migrations, human migrations from one region to another. And they are boosted by storm surges. The tidal variation will also be magnified, isn't it? If let's suppose the sea level, if let's suppose this is the land, and the sea is at this level. So in the high tide, it will come up till here. Slight variation. If let's suppose the sea level is already here, during the high tide, it will come here. And also when the sea level will rise. For example, right now in Chennai, what we are witnessing a very high amount of coastal water flooding the coastline due to the storm, the heavy winds which are bringing the water inland. Now, as the water level will increase, that coastal flooding will also increase. By the way, as few of you had asked me, this Saturday, for the optional geography optional webinar, we shall be conducting a session on cyclone Michong. Right? We shall again be talking about the concept of why is it that the cyclone moves in a direction like it is moving. We shall be covering the concepts of the portion of why the cyclone has occurred in this particular month, in the month of December. How is it that it is named? Why is it that the region of Andhra Pradesh and the region of Tamil Nadu, the region of Kerala, even Karnataka, why these are the regions receiving rainfall, the naming of the cyclone, everything we shall be covering comprehensively in this Saturday's webinar for the optional. But this is for those guys for the geography optional portion. Now, after this, so again, those of you for geography optional, you can attend that webinar. Now, when we talk about sea level rise, it threatens several low-lying areas. Now, global mean sea level rise in the past century has been around 0.2 meters. 0.2 meters, that is 200 centimeter, or rather 20 centimeter, is not very significant if you think about it. The 20 centimeter water rise, 20 centimeter, sometimes even in my bucket, I overfill it by 20 centimeter. What are you cribbing about? The entire world only 20 centimeter. But look at the rate of rise. For example, the average rate of sea level rise was 1.3 millimeter per year between 1901 and 1971. The average rate of sea level rise. It was 1.3 millimeter, 1.9 millimeter per year in the next 3 decades, 3.7 millimeter per year in the next 10 to 12 years. And in the decade that is 2013 to 2022, the last decade, sea level has risen by a whopping 4.5 millimeter per year. So in the earlier part of the century, what was 1.9 millimeter per year, in the 70-year period, average was 1.9 millimeter per year rise. In the last 10 years, it has almost more than doubled. By this rate, many of the regions are going to get flooded. So this is where you can observe that initially the rate of sea level rise was around 2.1 millimeter, increased to 2.9 millimeter, and now it has increased to 4.5 millimeter. This is the rate of increase is going to further move ahead. Okay, the rate of increase is further going to move ahead. This is 0.2 meter, Vasundhara, not 0.2 centimeter, 0.2 meter. Okay, now why has the sea level risen up? Sea level has risen up due to two factors. One is the melting of ice and snow and the glaciers. Melting of ice and snow and glaciers. And secondly, the sea level rise has been observed due to thermal expansion of water. Right? Water, due to getting heated up, has expanded. Right? So thermal expansion has explained 50% of the sea level rise during 1971 to 2018, while ice loss from glaciers contributed 22%. You don't have to know these figures at all, but just understand thermal expansion of water due to heating is quite significant. Now, rate of ice sheet loss increased by a factor of 4 in the past decades, and together these were the dominant factors for the rise of sea level. Now, what is the future going to look like? And observe how it is going to be very similar to our past history, just that it is going to be accelerated. So over the next 2000 years, global mean sea level will be rising by 2 to 3 meters if the warming is limited to 1.5 degrees Celsius. As per the Paris Agreement, as per the global consensus, our aim is to limit the warming to 2 degrees Celsius. And if we are ambitious enough, limit the warming to 1.5. So the best case scenario that we are looking at, we are staring at a sea level rise by 2 to 3 meters. Think about it. Many regions in Sundarbans, they will get completely submerged. Areas in run of Kutch will get submerged. Areas in the small islands in Pacific, they will get submerged. All of this will lead to humanitarian crisis, food scarcity. You will have migrants being pushed into various different regions, right? On the best case scenario we are talking about. Then, if the warming is limited to Vasundhara 0.2 meter, I am telling you the rise of seawater has been 0.2 meter. 0.2 meter is how many centimeter, my dear friend? When we talk about 0.2 meter, how many centimeter is this coming out to be? Please let me know. You guys are much better in maths than I am. Please let me know. What is 0.2 meter in terms of centimeter? Very simple. It is 20 centimeter. Where is the doubt in that case? Please represent your doubt. What is the doubt? The sea level in the past year has increased, in the past, in between 1901 to 2018, has risen by 0.2 meter, right? That means it has increased by 20 centimeter. That means, and that is accounted by a rise here by 1.9 millimeter per year, 3.7 millimeter per year, 4.5 millimeter per year. What is the doubt? Please talk about the doubt and articulate the doubt so that it can be solved. Okay. Mustafa, we always say limit temperature to 1.5 degrees to pre-industrial levels. That basically talks about the fact that prior to the era of industrial revolution, ever since the era of industrial revolution has come over, we have started producing so much amount of carbon dioxide into the atmosphere that it has led to warming. Prior to the era of industrial revolution, we were in a scenario where the temperature was almost consistent and warming, but ever so slowly. So when we are talking that the temperature rise in comparison to the pre-industrial era should not be more than 1.5, that means whatever was the temperature prior to the industrial revolution, that temperature should not increase by 1.5 degrees Celsius. Okay. How melting of Himalayan ice in long run will bring drought-like condition, Gaurav? Because why is it that the rivers in the Himalayan rivers are consistently filled with water? Because of melting of ice and snow. If the Himalayan rivers would not be would be filled by the melting of ice and glaciers, where would they have got the water? Only during the rainy season there would be excess water. Otherwise, just like the peninsular rivers, they would have limited amount of water during the rest of the year. Now, if that ice and snow melts, there will be huge substantial seasonal variation in these river water flow. What will that lead to? That will lead to scarcity of water. Sarita, where is that webinar being taken? So that webinar, for the optional guys who have basically taken geography optional, it is for those people, that the guys who have taken geography as an optional subject, it is that optional webinar, Sarita. Okay, and the details of it you can inquire from the IS Live. Now, if the warming happens to be around 2 degrees Celsius, the sea level rise in the next 2000 years, if the warming is at 1.5 degrees Celsius, over the next 2000 years, the water level will rise by 2 to 3 meters. It can rise by up to 6 meters if the warming is of around 2 degrees Celsius. If the warming is at 5 degrees Celsius, the current trend as we are moving ahead, the current trend is warming at a rate of 5 degrees Celsius. We are staring at a seawater level rise of 19 to 22 meter. Think about it. 19 to 22 meter is very easily like a two-storied building, right? So think about it, that sea water, wherever the sea level is, it will increase by almost two-storied building height. So many of the coastal areas will immediately be underwater. And then the past is or has also been very similar. So 125,000 years ago, the seawater was around 5 to 10 meter higher when global temperatures were close to around zero point 0.5 to 1.5 degrees Celsius higher than the current case, right? And around 3 million years ago, when the temperature was around 2.5 to 4 degrees Celsius warmer, the sea level was higher by 5 to 25 meters in different areas. So we are again reverting to that scenario of millions of years ago in a short time period of 2000 years. That is where we are going to bring about, and we are bringing across the planet irreversible changes, which eventually will lead to various issues. Okay. Now, the effect of climate change on food production will also be there. For example, in the immediate near term future, due to rising global temperature, melting of the permafrost, and warmer temperature in the temperate areas would mean what? That in these temperate regions, you will have a kind of a better climate or a warmer climate throughout the year in the temperate areas. And when you have warmer climate in the temperate areas, what does that mean? It basically means you have ideal conditions for growing crops almost throughout the year. Throughout the year, you can grow the crops. So crop productivity is projected to increase slightly at mid to high latitudes due to moderate atmospheric warming. But as the warming goes too high, there will be impact on the food productivity. For example, in the year 2022, India experienced the loss of the wheat crops due to heat waves, right? So that can be the case in various different areas and also in various different types of food crops, right? Example, always cite these examples, recent examples and examples around you, that will always be valuable. Wheat crop was destroyed in 2022 as India experienced heat waves in months of March and April. Okay. Now, according to IPCC, food will be plentiful for a while, right? Because of longer growing season in the colder areas also. But after that, as the warming will continue, you will have greater spell of dry conditions, drought-like conditions, greater period of absolute negligible food or heat waves. So in the long run, the food security will definitely be impacted. In the short run, it won't have much of an impact. The scientists warn that by the year 2050, some 200 to 600 million of the world's poorest and most vulnerable population will be facing scarcity of food. Health issues will also be there. Now, for example, extreme heat can lead to occurrence and causation of heat strokes. It can lead to heat strokes, right? Every year in our country, we lose many people due to events of heat strokes. Then also diseases will spread over to larger areas, vector-borne and zoonotic diseases shall spread to larger areas. Right. So here, when we talk about the diseases being spread to larger areas, what do we mean by that? For example, when you hear about the diseases like dengue, malaria, chikungunya, now you don't hear about these diseases in the region of, for example, Europe or Central Asia, or neither do you hear about these diseases in the cold regions of Canada, or neither do you hear about these diseases in the region of Ladakh. Nowadays, Jammu Kashmir, due to pollution, some areas they are experiencing it, but there also you don't experience it. Mostly, where do you experience these diseases? And malaria, dengue, chikungunya, in whichever areas of the country that you will experience it during immediately after the summer, during the summer condition when the rainfall starts, not during the winter generally, isn't it? So, warmer conditions are required. Vector borne means the diseases which can be spread by agents such as mosquitoes, etc. So, warmer conditions are required for these germs, these microbes, the mosquitoes to multiply in number. That is why the mosquito population that you find in the tropics is very high. You won't find those many mosquitoes in the temperate areas, do you? Now, with global warming, this will be able to spread even in the subtropical and the temperate regions of the world, increasing the incidence of these diseases in the larger area and the larger areal coverage also. Okay. Now, then natural disasters, because you have sudden increased amount of rainfall followed by a dry condition, you will have more floods, more incidents of flood, etc. will be observed, right? And as a result of that, there will be greater epidemic also, because whenever you have more floods, larger areas will be covered underwater. Epidemics like, for example, hepatitis, for example, even typhoid, all of that will spread. Malaria, they will spread very easily. Okay. Variable rainfall brings about lack of water security, brings about various amount of issues associated. So that is where health issues are also going to be prominently observed in the case of climate change. That is why, as we speak, as the Conference of Parties number 28 for the Convention on Climate Change, that meeting is taking place in UAE, in Dubai. For the first time, the world is also deliberating on the health issues. But this is a kind of a subterfuge or a kind of a diversion, a trick on the part of UAE, because of the huge amount of controversy that UAE has landed into. Because UAE has said that there has to be the usage of fossil fuels going ahead into the future. And that is where the president of the Conference of Parties had a kind of a very awkward argument with the UN Secretary General, where Secretary General basically said that if we are thinking about the future of the planet, we possibly cannot be thinking about the usage of fossil fuels. So there is a kind of dilemma, a kind of a no progress there. That is why it is also alleged that UAE is trying to divert the attention by talking about health issues and so on. Now, then, with the rising temperature across the planet, the sea surface temperature is also going to rise up. Sea surface temperature is going to rise up not only in the tropics but across. Now, as the sea surface temperature rises up substantially, there is formation of a tropical storm which can develop into tropical cyclones. We do know that warmer the sea surface, greater is the intensity of the tropical cyclones. And as this warming will become much more frequent, you will have much more frequent occurrences of these cyclones also. So here, these cyclones, due to increase in tropical ocean temperature, it basically will lead to increased increase in the areas influenced by tropical cyclones, even beyond the tropics will be impacted by it, then increased frequency of occurrence because the warming will happen very frequently, and also increased intensity of the storm due to high amount of warming. Okay, increase in the intensity of the storm because of high amount of warming. So that is where the impact of tropical cyclones will also be much more widespread. Coral bleaching, we do know that due to rising temperature, we are already experiencing in many of the portions the occurrence of marine heat waves. Marine heat waves are being observed. What is a marine heat wave? Where the temperature of the ocean water for a small duration increases by 3 to 4 degrees Celsius for a short duration. Temperature of seawater increases by 3 to 4 degrees Celsius for small duration. And that eventually can lead to coral bleaching. And coral bleaching, we do know, will have a very disastrous consequence to it because corals, they are responsible for providing shelter to a wide variety of species, and they are also enriching the oceanic region and the oceanic ecosystem by consistently providing availability of dissolved oxygen in the oceanic environment. Now, migration. Migration will happen of two types. Due to climate change, you have the migration of the species, migration of species, and here you will have both terrestrial species, terrestrial species, and maritime, marine species. Both of them have begun to migrate. Already you have many species of whales, which earlier would be found in the tropical regions of the world. Now, because the tropical waters are getting warmed up, they are migrating to the subpolar areas, covering thousands of kilometers in order to reach the cooler waters, the colder waters, for the availability of food. Right? So, as a result of migration, what will happen? Migration of species increases stress on resources, and leads to increased competition, which can lead to potential extinction of a few species. Right? Especially humpback whales, they are migrating to polar regions for low temperature. Yes, and also for availability of krill, also for the availability of the planktons, the zooplanktons in particular, the small fish, etc. So there, the availability is much greater in the polar and the subpolar areas. That is why the humpback whales are migrating for long distances. It is, by the way, a very unique pattern where the killer whales or the orcas, They have been smart enough to detect this migration pattern. And that is where, in the migration route, these orcas, they have begun to hunt, right? And as I told you, these are very evolved hunters out there, very, very evolved hunters. Even, for example, polar bears, their the habitat, the seals, the penguins, their habitat is shrinking. They are forced to migrate to various different areas also. But migration will also be human migration, where we can expect large scale migration of humans from one area to another due to maybe frequent occurrence of droughts, frequent occurrence of epidemics, natural disaster, flooding of the coastal areas. So that is what has also initiated a large scale human migration. For example, in areas of Sundarbans, where many of the regions have traditionally and historically, for generations, for hundreds of years, they have carried out paddy cultivation in many low-lying areas of Sundarbans. Now, due to flooding, many of these regions, they have got salt deposits, and due to those salt deposits, there are basically turning out to be infertile and unproductive, and the people are forced to migrate from that area to somewhere else, right? For example, even if you consider the region of Middle East, West Asia, they have suffered from incredible continuous and successive occurrence of droughts, and crop failures have been very common. It is because of these frequent crop failures where the prime economic activity of cultivation has stopped yielding any revenue. And as a result of that, people are pushed into picking up certain kind of migration, where they migrate across the Mediterranean. They meet a very woeful scenario once they are migrating. But this problem is going to exaggerate going coming ahead into the future. Now we have the impact of climate change, particularly for India. When we talk about India, the impact of climate change will also be almost similar. Extreme heat conditions will be observed. Changing rainfall pattern we are already experiencing. For example, this year, month of June was dry. Look at the month of July. We all witnessed the havoc that July created in the region of Himachal Pradesh. Himachal Pradesh, Uttarakhand, Sikkim, floodings, right, of a kind of a biblical proportion, which is undescribable. You have to be there to believe that. And then again, followed by dry condition. So you have the twin problems of flood and drought, which will be faced, right? Groundwater is getting depleted because of lack of rainfall. More there is lesser amount of groundwater recharge, more exploitation of groundwater is going to happen, right? Now, then glacier melting of glaciers, they will lead to water scarcity, right? Initially that will lead to flooding, and in the long run it will lead to water scarcity. Sea level is going to rise, agriculture and food security is going to be impacted. Now, due to warming of the climate, there is going to be an increased amount of energy which will be required, increased amount of electricity will be required. Now, during the summer months, always many of the areas across the country, they suffer from frequent power cuts and power outages. Why is that the case? That is because of the energy security, lack of energy security, isn't it? You have a general and a genuine lack of energy security. Energy is not available for everyone. Water security, health, migration, and conflict, these are the impacts of climate change on India. So, if a question comes about discuss the impact of climate change on India, you have to be able to discuss and describe these, write a couple of sentences about them, and more than sufficient. I'm sure you will be able to weave, if possible, even 500 words about the impact of climate change. Now, how do we mitigate? How do we mitigate that damage caused by climate change? One is carbon sequestration. Carbon sequestration, what is carbon sequestration? It is basically long term storage of carbon dioxide or other forms of carbon at the power stations, industrial sites, or even directly from air and permanently storing it underground. That is carbon sequestration. It is carried out by pumping carbon into the carbon sinks. right? You have the carbon sinks, and you have the carbon sinks which can be natural, which can be artificial as well. So here, natural sinks, oceans, forests, soil, whereas artificial sinks, depleted oil reserves, unminable mines, which are not economically viable anymore. In those areas, in all those regions, you continue to store significant amount of carbon dioxide, right? Now, other than that, when we talk about sequestration, sequestration is of various types. For example, ocean sequestration, the carbon capture which is happening naturally in the oceans. Geological sequestration in Earth's deep subsurface, right? For example, if you observe, carbon dioxide can be captured from the atmosphere. It can be stored into depleted oil and gas reserve, unminable coal beds where you are not going there to mine coal anymore. In And basically the depleted oil and gas reserve, if you pump in carbon dioxide, it might push in more oil eventually. Even that carbon dioxide that you are storing in the coal mines, that can also turn into an energy generating gas, syngas, as a result of that. You also have deep saline formations underground where you can store that carbon dioxide. So, deep saline formations, coal mines, unminable mining areas, depleted oil reserve, all these are the example of geological sequestration. Terrestrial sequestration in vegetation and soil immediately close to the surface. So, that is your terrestrial sequestration. So, you have different methodologies of sequestration. Now, it is in this context that when we talk about green carbon, as I had told you already, it is the carbon removed by photosynthesis and is stored in the plants and soil of the natural ecosystem and is a vital part of the carbon cycle. Okay, so carbon removed by photosynthesis and stored in the plants and soil of natural ecosystem. Blue carbon, that is coastal, aquatic, and marine carbon sinks, where the marine areas they absorb the carbon dioxide from the atmosphere. Okay, now understand, again I will tell you the reality of the planet Earth in terms of its history. Planet Earth has gone through multiple such phases where suddenly there has been an overflooding of CO2, and slowly and steadily it has been absorbed by the nature over a period of millions of years. Now, there has been multiple such events which is also referred to as carbon fertilization. Carbon fertilization. What is carbon fertilization? Carbon fertilization refers to increase in CO2 in atmosphere. Now, what will that lead to? When you have an increase in CO2 in atmosphere, what will that lead to? In the short run, plant growth will increase due to higher rate of photosynthesis. Okay. So, in the short run, this event can happen. Now, but in the long run, the impact due to warming, etc., will be very disastrous. Then we come to carbon offsetting. What is carbon offsetting? Offset. So basically, these are credits for reduction in greenhouse gas emissions made at another location, such as wind farms, which create renewable energy and reduce the need of fossil fuel powered energy. Carbon offsets are quantified and sold in metric tons of CO2 equivalent. What it means is basically, let's suppose you have different countries. All the countries have been given a set target in order to meet the emission, that you cannot emit more carbon dioxide than what is the given target. Let's suppose now any particular country, let's suppose, has got this much amount of emission. Its target is only this much. It is exceeding the target by, let's suppose, 5 tons or 15 tons of CO2. Right? So it is exceeding the target. So what can it do? It will offset that excess carbon dioxide emission by, let's suppose, this country will help install a kind of a wind energy or a solar plant or any kind of such kind of installation, which will reduce this is a country A. It will go to country B like India or Bangladesh, which require a lot of energy. It will end up building a solar power plant, a kind of a wind farm, etc., renewable, or anything for that matter, right? Which can prevent emissions of 15 tons of CO2 as a compensation, right? So it can go to the country B and do that. In return of that, it will get some credits. A will get credit worth 15 tons. So this will help country A fulfill its targeted obligation. Okay? Right? I hope that is understood. As EPR credits in waste management. Yes, almost similar to that, right? Where tons of CO2 are traded between companies who are in need. Yes, that happens. Okay? So here, worth of metric tons of carbon dioxide and carbon dioxide equivalent. Let's suppose you are able to reduce the amount of methane emission. So you convert that methane emission, for example, 1 ton of methane emission will be how much in terms of carbon dioxide equivalent? And then you award credit accordingly. Okay, so what offsetting is, let's suppose I am, and Baldev, listen to this significantly and listen to this carefully again. Suppose I am a country and I have a target given by the Paris Agreement or given by the Kyoto Protocol earlier that I cannot emit more than 75 tons of carbon dioxide. Let's suppose I have a target, I cannot emit more than 75 tons. Now, my natural economic process and production tells me that this year I am going to produce 90 tons of CO2. Your question can be that why can't I reduce to 75 tons? Let's suppose that all the vehicles, I cannot remove the vehicles almost within the year. I cannot shut down the industries within a year. Maybe in the long run, I can reduce it in 5 years, but immediately I cannot. I am going to produce 90 tons, whereas my target was 75 tons only. So how do I fulfill that target? How do I fulfill that obligation? So what I can do is that, okay, if I am not able to reduce the emission, I will help overall the planet reduce the emission. So I will go to a country like India, where maybe they are in India, we are requiring a lot of energy. We are establishing more and more thermal power plants. All these thermal power plants produce carbon dioxide. A lot of carbon dioxide is produced on an annual basis, right? So I go to a country like India and I tell them that rather than opening another thermal power plant, let me help you establish a solar power plant so that in thermal power plants, you would have released 20, 40 tons of carbon dioxide. Thereby, you will be able to save that much amount of carbon dioxide emission. So I go to another country B, and there in that country B, I help reduce the CO2 emissions by installing new projects worth around, let's suppose, 15 to 20 tons. Okay, so country A will get carbon credit worth around 15 to 20 tons. And observe, my emissions are going to be 90 tons. My target was 75 tons. So now that I have got a credit of 15 tons, I will be able to fulfill the obligation. So India has also benefited. I, as a country who had a target and I was exceeding the target, I have also benefited. Okay. So, yes, ridiculous. That is correct. So that is basically you have the carbon credits. Now, there is also a factor of carbon tax. What is carbon tax? Carbon tax is when you have basically a kind of a cap and trade where, let's suppose, I have fixed a target for the automobile sector. In India, I have to reduce the emission in 5 years. I have fixed the target. That automobile sector, for example, cannot emit more than 20 tons. Now, in that, I say that if you are going to emit more than 20 tons, you will have to pay tax for each ton that is produced. So, by that also, I will be disincentivizing the production and generation of carbon dioxide. I will basically be reducing the amount of carbon dioxide emission. If a company, if a country is doing that, they will have to pay tax for it, right? So it is a potential alternative to the cap that you are putting, cap and trade. And aim of the tax is to cause less fossil fuel use and hopefully cause an incentive for other sources of energy utilization. Okay. Now, after this, we come to geoengineering. What is geoengineering? So basically, geoengineering is one of those artificial methodologies that you can bring into the picture in order to modify the climate by understanding that how we can reduce the rate of warming. You bring various different modifications, you bring various different changes, and this is much more theoretical in the concept where you are talking about reducing the rate of warming by bringing changes. For example, placing mirrors in space. Think about a scenario where we could place mirrors in space. If you could come to that situation, the mirrors would be reflecting the solar rays and they would have caused cooling, and they will cause cooling on the ground surface, isn't it? Whitening the stratosphere with sulfate aerosols. Again, that will be able to reflect the solar rays and again provide cooling, right? Whitewashing building roofs to reflect sunlight, again, to reduce the amount of heating. Now, hoisting parasols. What are parasols? Parasols basically are these kind of architectural construction that you can basically, the concept is that if you place it in a very large area, this will be reflecting solar rays. So on the ground surface, it will provide cooling. Natural cooling will be observed on the ground surface, isn't it? Here, flinging iron filings into the oceans. Now, if you fling iron filings into the oceans, these serve as nutrients for growth of algae. Growth of algae. Now, if that algae grows, plankton population, that is, population increases, means photosynthesis increases. Photosynthesis increases means CO2 is consumed, oxygen is produced in significant quantity, right? So these are few of the things that we can do artificially in order to provide the flinging of iron. Flinging means, what is flinging? The meaning of flinging. Are we aware about the meaning of flinging? Iron filings basically refers to the shaved portion. So, for example, I don't know how many of you have done that in your. Okay, no idea about the meaning of flinging or filing. Okay, how many of us have no clue what is the meaning of flinging and what is the meaning of filing? Then this will make no sense at all. So, I don't know how many of you have done that kind of a workshop in your school days or in your college days where you had to file the iron, where with the help of the various different types of chisels, you basically had to smoothen the iron. Iron filing is where you basically rub against it in a repetitive motion, and you have small morsels of it, which are irregular pieces. They basically, the small strips, the small parts of it, they start separating. So these are the small particles of iron which get shaved off from the larger piece. That is iron filings, the small portion. Flinging means, flinging is, yes, in engineering mechanics you would have done that, I'm sure. Right. So flinging is, yes, iron dust, you can think about it. Flinging is throwing it off. Throw it off in the ocean. That will provide the nutrients for the growth of algae. Okay. Right. Yes, and after that, magnetic. Yes, so many of you have done that kind of an experiment in your school, so, or in the college, like sharpening of knife. Good. Like you sharpen your knife, you have small particles of it, small shavings of it. Credit is not in terms of money. No, you can pay a country to earn carbon credit, but credit is not given in terms of money. Yes, Anurag. Sadly, that is the case. So that is the case of geoengineering. So geoengineering basically has got the potential to provide or to halt the rate of warming and to provide the cooling. So whitening of the clouds by sulfate aerosols, artificial mirrors in the space, greater amount of sequestration, all of that leads to the process of cooling. Okay. Now we will come to the portion of biodiversity. We'll talk about it tomorrow, and tomorrow we discuss few of the PYQs related with this area also. I hope the session was understood. This is a very important session for your examination, very important module for your examination perspective. Now, let's take few questions and we'll end the session.